This is section 5.2 called Sum and Difference Formulas. So let's just kind of review the formulas you're going to be using in this section. It is exactly what it says it is. It is finding the trig functions of the sum of two angles or the difference of two angles. So rather than writing the formula two different times here, we just kind of combine the. So basically the sine of angle A plus angle B is equal to the sine of angle A times the cosine of angle B plus cosine of angle A times sine of angle B. So if you have a difference, sine of angle A minus angle B, that would equal sine of angle A times cosine of angle B minus cosine of angle A, sine of angle B. Okay, so if you go with the top sign, if it's a sum, you go with the top sign. If it's a difference, you go with the bottom. So on the sine, plus, if it's a sum, it's a sum here. If it's a difference, it's a difference here. Okay. Let's go to the cosine. So if you have the cosine of the sum of two angles, the cosine of angle A plus angle B equals the sine of angle A times the sine of angle B minus the cosine of angle A times the cosine of angle B. Where if you have the cosine of a difference, notice the sign here is going to be a plus. So it's going to be opposite whatever it is in the. If it's a sum, the sign over here is going to be a subtraction. If it's a difference here, it's going to be a sum. But notice the difference here that this one is sine A cosine B, cosine A sine B, where this one is sine A sine B, cosine A cosine B. So you want to kind of remember those formulas. And then tangent is totally different. But the tangent of the sum of two angles is the tangent of angle A plus the tangent of angle B divided by 1 minus the product of the tangents of A and B. So tangent A times tangent B. So the sign on the top is plus, sign on the bottom is minus if you go with this, if it's a sum. Okay, if it's a difference, everything's the same except we would have the difference of the two angles on top and then the sum on the bottom. So the top matches. If it's a sum, it's a sum here. If it's a difference, it's a difference here. And whatever it is up here, it's the opposite down here, if that helps any. So it kind of gives you, use some of those kind of things to help you remember those formulas and keep them straight. Okay, so this is what we're going to do. Now, the biggest thing to avoid, let me just make a note up here to be careful of. Let's say I'm going to go with sine as this example. Say I have a sine of the sum of two angles. And this does not equal this. You cannot do this. And that because it looks like a distributive problem, and that would be a common mistake that someone might make. But we're not multiplying sine by this. This is, remember, you're taking the sine of the angle. So the sine is relating the size of the angle to the length of the opposite side compared to the hypotenuse. Basically, that's what it is. So sine doesn't make sense without an angle following it. So it's not a multiplication. It's you're taking the sine, you're relating the ratio of the sides opposite the hypotenuse to the size of the angle. So it's not a multiplication. You're not going to distribute. So this is a big no right here. So we'll just say be careful with that, because that would be a. So sine does not equal, sine of A plus B does not equal the sine of A plus the sine of B. It equals sine of A cosine of B plus cosine of A sine of B. Okay. All right, let's look at the first example. So it just says find the value of a sine of 15 degrees. And 15 degrees is not one of our common angles. It's not a 30, a 60, a 45. So yeah, you could put it in your calculator, but you're not going to get an exact value if you do that. So it says find the exact value of the sine of 15. So the trick with this one is we're going to use our sum and difference formulas. Now you may be thinking, well, how would I use a sum and difference formula when it's just a single angle? Well, that's the trick, is we're going to write 15 degrees, or whatever the angle is, as the sum or difference of two of the common angles. By the common angles, I mean the 30, 45, 60, and then also we know the values for the quadrant angles, which are the 90 and the 180 and the 270, 360, if you want to go on. So any of those angles, if you can make this, write this as the sum or difference of two of these angles. So for example, I could write 15 as 45 minus 30. So to find the sine of 15 degrees would be equivalent to finding the sine of a 45-degree angle minus a 30-degree angle, since 45 minus 30 is 15. Okay, I can do this because it tells me right here exactly how to do that. So the sine of the difference of two angles, so I'm going the bottom difference, it's going to be the sine of A times the cosine of B minus the cosine of A times the sine of B. So this is basically my A, this is basically my B. All right, so we go right through and doing what it says. So the sine of 45 degrees times the cosine of B, which is 30 degrees, minus the cosine of 45 degrees times the sine of 30 degrees. This is my A, B, A, B. But it's sine, cosine, minus cosine, sine. Now the good thing, the beauty of this is that I know the sine of 45 and the cosine of 30 and the cosine of 45 and the sine of 30 because they're common angles. So the sine of 45, the exact answer is square root of 2 over 2. The cosine of 30 degrees is square root of 3 over 2. The cosine of 45 is also square root of 2 over 2. And the sine of 30 is 1/2. All right, let me clean that up just a little bit. So square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. And I'm going to say it probably will take it this way. You could go ahead and combine it into one fraction as well. Okay. But I feel like, excuse me, I feel like WebAssign's pretty liberal on what it takes, so it probably would take it this way or this way, and this just combines them together into one fraction. Example 2, so kind of going back to our previous section, prove, so that's familiar, that sine of x plus pi halves is equal to the cosine of x. So we already know the answer, we know what we want to get to, but we want to start here and show that this is equivalent to this. Now this is the sine of an angle sum of two angles. So I can always interchange that with what's equivalent to the sine of the sum of angles up here with my angle sum formula. So let me do that. Let me expand this using the angle sum formula. So the sine of x plus pi over 2 is equal to, so it's sine, so sine, cosine, cosine, sine. So sine A cosine B plus cosine A sine B. Okay, so let's I know the cosine of pi halves and the sine of pi halves, so remember that's a 90-degree angle, that's here. Use the coordinates on the unit circle, so the cosine is 0 and the sine is 1. All right, so I have sine x times the cosine of pi halves, which is 0, plus the cosine of x times the sine of pi halves, which is 1. All right, anything times 0 is 0. Cosine anything times 1 is itself. 0 plus cosine x is cosine x. Done. I proved sine of x plus pi halves is equal to the cosine of x just through using my angle sum formula, just replacing this with something equivalent to it, and then basically just evaluating those angles that I could evaluate, those trig functions that I could evaluate because I knew the angle, and then just simplifying from there. All right, example 3. So in this problem, we're kind of going backward from what we've done in the other examples. Cosine of 5x times cosine of x plus sine of 5x times sine of x. Write that as a single cosine function. So if you look at this, cosine of a sum becomes a difference over here. The cosine of a difference is the sum. Since this is the sum, that means that the angle, it's going to be the difference of the two angles. All right, and the two angles, my A and B, are basically 5x and x. So this should be just really nothing to that, just simplifying cosine of A as a difference, so A minus B, so cosine of 5x minus 1x. Well, 5x minus 1x is 4x, I'm sorry, so cosine of 4x. And so cosine of 4x can be written as cosine of 5x minus 1x, and if you apply the difference formula to this, this is what you would get. Cosine of 5x, cosine of x, plus sine of 5x, sine of x. And that's all there is to that one. Okay, moving on to example 4. Very similar to example 2, except we're doing cosine this time. We want to show that the cosine of 270 degrees plus some angle B is equal to sine of B. So this is a cosine of a sum. And so I want to make sure I use the appropriate formula for cosine of a sum. So cosine of a sum is equivalent to the cosine of A cosine of B, sum here, so difference here, sine of A sine of B. Okay, so the cosine, I went ahead and sketched over here 270 on the unit circle, 0, negative 1. So cosine is 0, sine is negative 1. So cosine of 270 is 0 times the cosine of B. Sine of 270 is negative 1 times the sine of B. Okay, and then just simplify. 0 times anything is 0, minus a negative 1 times sine B, so it would be plus sine B. And 0 plus sine B equals sine B. So I proved that the cosine of 270 degrees plus some angle B is equivalent to the sine of that angle B. All right, for example 5, a little different aspect. We're going to graph this function. Now, I had a typo in the notes, so if you are pulling the notes from Google Classroom, this should have been a sum, and on the notes it has it as a difference. We could do it either way, but I'm just going to go this way. It makes the thing a little bit easier to graph. So if you want to go ahead and make that subtraction there, plus I've already done it on mine. Okay, so looking at this, I'm going to be graphing 5 times. This whole part right here should look very familiar. Matter of fact, if you look back at example 4, it looks exactly like what we were working with up here. So if you see cosine A, cosine B, plus sine A, sine B, looks just like this one except the signs, the only thing that's different. So I can condense this down into a cosine, but it would be the cosine of a difference instead of a sum. So I can write this here as the cosine of, this is my A, my B. So it should be the cosine of A, or of 6x minus 4x. Okay, and then don't forget the 5 there, so let me go ahead and bring that down. So I basically just, straight from the formula, the sum and difference formulas, I condense this down into the cosine of a difference. And then I can go ahead and simplify. 6x minus 4x is 2x. And so basically that's what I want to graph. And we've graphed that in the previous section, so this isn't too bad. So we basically want to graph the cosine function with a period change and an amplitude change. We want to graph it on the interval from 0 to 2 pi. So let me go ahead and set up my graph here so let's say here's pi, here's 2 pi, 0. So go ahead and kind of split our intervals there into our 4 key points to make it easy to graph. Get ready. My amplitude is 5, so I'll go ahead and take that. There's been no vertical shift, so it goes up to 5 and down to -5. Okay, it's a cosine function. Okay, and it is, we have had a period change, so to find the new period, remember I can take 2 pi divided by b. B is the coefficient of the angle, and that gives me the new period, which is pi. And let me just make a note that the amplitude is 5. So from 0 to pi, I'm going to get one full cycle of the graph. It wants me to go all the way from 0 to 2 pi, so I actually see 2 full cycles of the graph. All right, and so with it being cosine, remember cosine starts at the maximum, 5, and then 0, dips down to its minimum, back to 0, and back to its maximum. And let me just repeat that for another period here. All right, and so this is what this graph would look like. All right, so you can see the amplitude, and you can see what the impact that the 2 had, multiplying that angle, doubling that angle has a horizontal shrinking factor, and that's what the graph would look like, 2 periods of it. Number 6. Very similar to the very first angle we did, where we wrote I think it was a sine of 15 degrees, and we wrote that as 45 minus 30. Yeah. We want to do the same thing, but this is a cosine, and so the trick to this problem, just like the trick to number 1, was to determine what common angles we're going to break 5/12 into. It can be a sum or a difference. There's probably more than one correct answer, or more than one correct way to do that. But this was going to be a little bit more challenging just because of the fact it's in radians. We got to do all the fractions, and so so let me play around with some numbers right now. I'm trying to figure out how I can get 2 angles to equal 5 pi 12ths. So just to make it easy right now, I'm going to keep everything in terms of 12. So let's try some different things here. Let's say, what if I do 2 pi 12ths? Now you may say, is that not a common angle? But that reduces to pi 6. So if you just take your common angles, there's pi 6, that's 30 degrees, pi 4, so that's the 45 degrees, and pi thirds, and that's the 60 degrees. If we make those all in 12ths, this would be 2 12ths, this would be 3 pi 12ths, and this would be 4 pi 12ths. Okay, so these are kind of my common angles I want to work with. But as I'm looking at these right here, 2 pi 12ths and 3 pi 12ths. Well, there you go. That gives me my 5 pi 12ths. So that's the same thing as pi 4. So basically, pi 6 plus pi 4 equals 5 pi 12ths. It's just harder to see it from here because they don't have the same denominator. So I could use this as my angle sum and go with it. Another one I could, let's see if there's another one I can do. I could do, of course you have to use the other quadrant angles off of these, but I could do 9 pi 12ths minus 4 pi 12ths would also work. This is the same as 3 pi 4ths, which is one of the multiples of pi 4ths, and this is pi thirds. So there's a difference that would work. So there's multiple ways you could do it. There's not just one correct answer, but I'll just go with the sum. You could do either one of them. So cosine of 5 pi 12ths is equivalent to the cosine of pi 6 plus pi 4ths. All right, and then from there, it's just pretty much straight up applying that cosine of a sum formula. So cosine of a sum, if you got your formulas handy there, remember cosine of a sum is the cosine of A, which is pi 6, times the cosine of B, which is pi 4ths. Sum here, so it's a difference here. Sine of pi 6 times sine of pi 4ths, straight from the sum and difference formula. All right, and so pi 6, the cosine of pi 6 is square root of 3 over 2. Cosine of pi 4ths is square root of 2 over 2. Sine of pi 6 is 1/2, and the sine of pi 4 is the square root of 2 over 2. Okay, so this is square root of 6 over 4, square root of 2 over 4, just doing the multiplication. And again, WebAssign will probably accept this as an answer, but I don't know if it may or may not. But you'd go ahead and combine those into one single fraction by saying square root of 6 minus square root of 2 over 4. This is a little more simplified way to write it. And so that would be the exact value of the cosine of 5 pi 12ths. Okay, so let's look at example 7. All right, we are asked to find the sine, cosine, and the tangent of a minus b. So this was going to be a little bit of work, just kind of time consuming because you got to do that expansion of the difference formula for sine, cosine, and tangent. So, all right, so sine, let's start with the sine of a minus b. Literally just directly from the formula for sine of a difference. Sine of a difference is equal to the sine of a times the times the cosine of b minus the cosine of a times the sine of b. Okay, well, I don't know this. They give me the cosine of a, so I know this. Give me the sine of b, so I know this. So I don't know either one of these. Let me go ahead and fill these in. So minus cosine of a is a negative 7 over 25. Sine of b is a 40 over 41. This is the subtraction coming down. So I don't know sine of a or cosine of b, but I can find, if I know the cosine of a, basically I know the adjacent side and the hypotenuse, and therefore I can find the opposite side. We did that back when one of the early sections. So let me just sketch it out down here. Okay, so this will be angle A. And it tells me that angle A lies in quadrant 3. So this is my angle A. I know that the adjacent and the hypotenuse are given, so basically adjacent -7 to hypotenuse 25. You know, that's a common Pythagorean triple. If you know 7, 24, 25, then you don't have to work it out. But if you don't, you just do a squared plus b squared equals c squared, use your Pythagorean theorem, and you'll find this is negative since the y in quadrant 3 is negative. So basically from the cosine, I am able to find the sine and the tangent and any of the other functions that I need. Okay. I also need to know the cosine of b. Okay, well, from the sine of b, I'm going to have to use that to find the cosine of b. And so this lies in quadrant 1. So quadrant 1 angle b. All right, and so from the sine of b opposite to hypotenuse. All right, again, if you know 9, 40, 41, if you don't, do the a squared plus b squared equals c squared. But you know, that's just some things that can save you time. Those are just ones that come up. They're fairly common Pythagorean triples. This one may be a little more common than that one, but any rate, if you don't know, you just do a squared plus b squared equals c squared. Use your Pythagorean theorem. Okay, so I need the sine of a. So from angle A, sine opposite to hypotenuse. So this is going to be -24 to 25. And then cosine of b from angle B, this is adjacent to hypotenuse 9 to 41. All right, and so finally, all I need to do is a little bit of just basic fraction calculations here. 24 times 9, I don't have a calculator handy here, so bear with me, is -216. 25 times 41 is 1025. All right, and I'm going to go ahead and make this plus since it's minus a negative. 7 times 40 is 280. 25 times 41 is 1025. All right, and so -216 plus 280 is +64. And so that is the sine of the difference of the two angles. If the cosine of A is this and sine of B is this, that's what the sine of A minus B would be. All right, let me do the cosine of A minus B. Now, that'll be a little easier because we don't have to do this every time. We'll reuse these. All right, so the cosine of the difference. So again, go back to your formulas. The formula for cosine of A minus B is cosine of A cosine B plus sine A sine B. All right, and so cosine of A, I know, they give me that. Cosine of B, I don't know, but I can find it. Cosine of B, adjacent over hypotenuse, 9 to 41. Plus sine of A, don't know it, but I can find it. Opposite to hypotenuse, negative 24 over 25. And sine of B, that's given to me 40 to 41. All right, and so basically it's just, again, a little bit of calculations here, multiply the fractions together and then add them. And so this is going to be negative 63 over 1,025. This is going to be negative 960 over 1,025. And combining these is going to give me negative 1,023 over 1,025. All right, and finally, tangent. All right, again, straight from the tangent formula. So it's the tangent of A minus the tangent of B over 1 plus tangent A times tangent B. All right, well, I'm not giving any of these directly. I'm going to have to find them off from the triangles here. So the tangent of A, opposite over adjacent, negative 24 over negative 7, which is going to be 24 over 7. All right, minus the tangent of B, opposite over adjacent, 40 over 9. All right, the denominator, 1 plus, and then I've got to multiply the tangent. Well, here's the tangent of A and tangent B, so basically it's just 24 over 7 times 40 over 9. All right, so 24 times 40 is 960. Oh, wait a minute, I don't have a common denominator. Let me back up. Back up a minute. Okay. So let's give them the same denominator. So I'm going to multiply this by 7, which means I need to multiply that by 7, and multiply that by 9. And so that makes my denominators both be 63. All right, and so 9 times 24 is 216. 4 times 70 is 280. All right, and now down here I'm going to go ahead and do 24 times 40. That is 960, and 7 times 9 is 63. Okay. Same denominator, I can combine these together. So this is going to be negative 64 over 63. And you're adding 1, so just think of this as 63 over 63, and 63 over 63, and 960 over 63 is 1,023 over 63. Okay. Last thing, I have a complex fraction here. I don't want to leave that way. No fractions within a fraction. So let's do what we've always done. It's elementary school. Remember the keep, switch, flip, or however you learned it. So this is the numerator. Dividing by a fraction is the same as multiplying by its reciprocal. So we flip this one. These divide out, and I am left with negative 64 over 1,023. And that is the tangent of A minus B. All right, last example. Example 8. So kind of just like example 7, this time we don't have to do quite as much work though. Only have to find the tangent this time. All right, so let's see. The tangent of A minus B equals, so straight from the formula. The difference, so it's going to be the tangent of angle A plus the tangent of, oh, my bad, minus actually. Minus the tangent of angle B over 1 plus tangent of angle A times tangent of angle B. Okay, so what do we know? Well, we know the sine and the cosine. We know the sine of A and the cosine of B. So we're going to have to do a little bit of work to be able to get the tangents by both of these. So we'll sketch this out here. So for angle A, all right, so we're in quadrant 3. So it helps me draw it in the right place. So there's my angle A. The sine is opposite over hypotenuse. So 8, again, Pythagorean theorem will do this for you, but if you know some of the common Pythagorean triples, 8, 15, 17 is 1, but if you don't, work it out, do Pythagorean theorem. All right, and then for angle B lies in quadrant 1 with a cosine of 7 over 25, so the adjacent to the hypotenuse, and again 7, 24, 25. And that saves you some time if you know some of those common Pythagorean triples, but you can always do Pythagorean theorem. So, okay, so what I do know is now this is angle A. I need the tangent of angle A. Well, the tangent is opposite over adjacent, so a negative over negative is a positive, and it would be 8 over 15. Tangent of angle B, opposite over adjacent, so 24 over 7. 1 plus tangent of A, which I've already got, 8/15, times tangent of B, which is 24 over 7. And then I've just got to do a little bit of the simplifying with the fractions and math. So, all right, so common denominator here, let's make this 15. Let's make this multiply by 7. So this becomes 56 over 105. 24 times 15 is going to be 360 over 105. Down here I've got 1 plus. 8 times 24 is going to be 192 over 105. All right, so 56 minus 360 is negative 304 over 105. So that's the top fraction simplifies to be. And the denominator, it's just 1, so think of this as 105 over 105. 105 and 192 is 297 over 105. And then we'll simplify. We don't leave a fraction over a fraction. That's a complex fraction. So let's take the negative 304 over 105 and switch to multiplication, flip it over. And those 105s divide out, and we end up with negative 304 divided by 297. All right, so I found the tangent of the difference based on what I was given there.